Number 7, consider X which follows normal distribution in parameters mu and 4. Okay, find the value of the mean given that probability that X is less than or equal to. Okay, good. So this distribution, it has to be in this form. So X is normally distributed with parameter that and 2 squared. That's how we write it. And if we write it that way, the standard deviation will be 2. Anyway, we're just writing it so that it's more its proper form, not the way it is there. I mean, 2 squared is 4 anyway. So let's carry on. Find the value of this. So what we need to do here is you can transform the X values to z-scores because you don't know what the mean is. We can use our calculator, but well, a proper way is to transform to z-score. So transform X value to z-score. Okay, if we do that, what we'll end up with an equation that can help us to find what the mean is. So if we transform that, we'll have our X value, which is 2, minus the mean divided by the standard deviation, which happens to be 2, will be equal to inverse normal. Now remember, inverse normal gives us the X values, but since we transform to a z-score, it will give us the z value basically on the standard normal distribution. So this is z-score, so it gives a z value on the standard normal curve. So the parameters, the area does not change, so the area will still be 0.556, but the parameters, because you are now working on a standard normal curve, the parameters will be 0 and 1. Okay? Remember, our goal is really to find the mean, and we want to form an equation that can help us to get that. This will be equal to 0.1408. So basically what we'll have is 2 minus the mean will be equal to 0.148 multiplied by 2. So I'm just going to multiply 0.148 multiplied by 2. Just write the mathematical process here. 0.28. Good. So basically my mean will be 2 minus 0.2816. Which is 1.72 to 3 significant figures. So that's how you work it out. Remember, the first thing is transform X value to z-score, and then the values that you're dealing with here are values on the standard normal curve. So you're dealing with z-scores now. No longer you're not working with x values. It's z-scores once after transforming to z-score. And then what you need to do is just to make the mean the subject of the formula to get what you want. Number 8, consider a random variable x which follows normal distribution with parameters mu and that. Find the values of the mean and standard deviation. So we are given these two conditions, that and that, and what you're going to do here is to try and basically do the exact thing that we've done here. Transform x values to z-scores using these two conditions. We'll end up with two equations and then we solve them using simultaneous equations. So transform x values to z-scores. I'll start with the first condition on the left. So which means that 2 minus the mean divided by the standard deviation, we don't know what they are, will be equal to inverse normal of the area does not change, 0 and 1. Now if you plug that in your calculator, you'll get 0.1156. If you go second inverse normal, the area is 0.546. You'll end up with that. All right, 4 decimal places. So we end up with that. And we can go ahead and say 2 minus the mean will be equal to 0.1156 multiplied by standard deviation. And this equation will be, we can write it as that, just bringing the mean to the right. That will be equal to 2. And that will be our first equation with two unknowns. And then I'll move to the next condition that you're given, which is the probability that x is less than or equal to 3 is equal to 0.743. So transform these x values to z-scores. You'll end up with inverse normal, 0.74301. If you plug that in a calculator, you'll get this value, same thing as what I did previously. So you'll have 3 minus the mean is equal to 0.6526, that, which can be written as bring the mean to this side, and that will be equal to 3. This is our second equation. So we can solve this simultaneously on our graphing calculator. So if you go onto your graphing calculator, just go onto second, actually go onto apps, Polysmalt, simultaneous equation solver, two unknowns, yes, next, and then just plug in. So 0.1156, 1, 2, 0.6526, 1, 3. If we can find our answers in decimals, and we have what we need. So our standard deviation is 1.86. Our mean is 1.78. So we can say standard deviation is equal to 1.86 and the mean is equal to 1.78. Okay. Number 9. The random variable x is normally distributed with the mean and standard deviation both are known. Given that the probability that x is greater than 58.44 is that, and that. So we have these two conditions. Find the values of these parameters. So let me start with this one here. We are basically going to transform x values to z-scores. Same method that I've used in the previous two examples. Now, this is very important since the probability that x is greater than 58.44, this is an x value, is equal to 0.022. That means that area to the left of x will be given by uh, 1 minus 0.022, which will be equal to 0.978. All right. So area under the curve is equals to 1. And if you want to find the area on the other side, you just subtract from 1. Okay. And then we can now convert this guy to a z-score. Okay. So we can say that 58.44 minus the mean over standard deviation is equals to inverse normal of area. Remember, this is how you'll plug in your calculator. Now, if you plug that in your calculator, you get 2.014. And then you can go ahead and rearrange this which will give you 2.014 standard deviation plus mean is equal to 58.44. Again, we are given that the probability that x is less than 48.84 is equals to 0.012. So we can transform this to z-score. So 48.84 minus the mean divided by the standard deviation will be inverse normal of the area, which is 0.012. And those are the parameters. And this will give us negative 2.257 if you plug it in your calculator. So we have, remember this was a first equation. We need a second equation. So this can be given as 48.84 minus the mean will be equal to negative 2.257. That. So if you bring this to one side, negative 2.257, that plus the mean will be equal to 48.84. Let's call that second equation. All right. Now, what we can do is we can plug this in our calculator. So if you plug this in your calculator, so start with the first equation, 2.014, 158.44, negative 2.257, 1. So what I'm just plugging in is the coefficients of these guys. And then you'll end up with this. So from here we can see that our standard deviation is 2.25 to 3 significant figures, and our mean is 53.9. So our standard deviation, 2.25, and our mean is equal to 53.9. Okay, move on to number 10. A machine is used to fill 1 kilogram bags of flour. When the bags are checked, it's found that their average weight is 1.03. So that's very important. Average weight. Assuming that the weights of the bags are normally distributed, okay, find the standard deviation. So these are normally distributed. We want the standard deviation if 1% of the bags weigh below 1 kilogram. All right, give your answer to the nearest 0.1 gram. So what we need to do first of all here is to define our distribution. So we'll say W follows normal distribution with parameters 1.03 because that's the mean, and we don't know what the standard deviation is. So the first thing that we need to do is we are given this probability that W is what is that? 1% of the bags weigh below 1 kilogram. Below 1 kilogram. 1%. That's 0.018. Good. So transform to to z-scores. What I'll end up with here is 1 minus the mean divided by the standard deviation will be inverse normal of that area. The area doesn't change if you transform this. If you plug that in your calculator, you'll get negative 2.097. I showed you how to do it. So what we'll end up with here is negative 0.03 over standard deviation will be equal to negative 2.097, which means that the standard deviation will be equal to negative 0.03 divided by negative 2.097. If you plug that in your calculator, you'll get 0.0143 kilograms. And if you convert that to grams, that will be 14.3 grams.